All right, folks. Oh, excuse me. Let's go over an example that was similar to the one we did in class. I hope to do a couple of videos like this with just some different numbers, and hopefully also create a practice quiz that you can try things out on. But for starters, let's try this. All of these conditional probability questions concerning, say, medical exams run the same way. There's some condition, there's some frequency of occurrence, there's some test, some way to determine if you have it or not, and it has some accuracy. Now, the way we're going to solve these in 101 is by analyzing frequencies instead of probabilities. Probabilities are the last thing we calculate. So we pick a nice round number, and it can be any number. So we could suppose we have a sample of 10,000 people. Oops, can't spell very well sometimes. Randomly selected. All right. So the randomly selected means that this population should have the same 2% occurrence. So if we want to know the odds, if we want to answer this question here, that you receive a positive test result, what are the odds that you actually have the condition, then we need to know how many positive test results we'll find in this population. So step one, how many positive test results will there be? And there are two ways that we'll get a positive test result. There are true positives. These are positive test results of people who do have the condition. And then there are false positives. So these are people who get a positive test result but do not have the condition. Let's start with the true positives. First, we need to figure out 2% of 10,000. And the reason we want that number is we're supposing, getting my calculator, that 2% of the population has this condition. And this would be determined through experimental probability. There's no way of theoretically calculating this. Let's see if I can. You may not be able to see that screen. No, you can't, so I'll just do it off camera. So to do 2%, this requires 0.02 times 10,000, which is 200. Yeah, it's just 200. Right, so there are 200 people out of 10,000 who actually have X. Okay. And so similarly over here, well then the other people don't. So 10,000 minus 200 is 9,800 do not have X. Now let's see what the test results are. So this test is not 100% accurate, and so we're going to have false positives and false negatives and whatnot. In the population of 200 people who do have it, we need to find out how many true positives. The true positive will be, if we take 97% of 200, because this is the accuracy of the test. The test should accurately diagnose 97% of them. So that's 0.97 times 200, is 194 true positives. So that means that there are 200 minus 194, so 6 false negatives. And this does take a little bit of thinking with these words. So a false negative means they do have the condition, but the test didn't catch it. And this is actually the reason for doing more than one screening. Because no test is 100% accurate, the odds of having a false negative, we could calculate that, maybe we will, they go down with each test result. The tests are presumably independent. So if you take one test, the next test shouldn't increase or decrease the odds of finding anything. So if you hope to reduce this number, right? In practice, you want to develop a screening process to avoid this. These would be individuals who have a condition and we're not finding it. This is bad. This is unfortunate. They're not getting treatment or interventions. Now over here, there are 9,800 people who do not have X. So the test, which is 97% accurate, should give 97% of these people the correct diagnosis. So this is 0.97 times 9,800. So that's 9506. So these people have true negatives. This is correct. They don't have the disease. 9,506 of them receive the correct diagnosis. You're clear. Don't worry about it. But that means, because they're not the same number, that there are some people who don't have the condition who receive a false positive. 294 receive a false positive. So these 294 receive a positive test result, but they don't have it. So let's summarize here. Put this on another sheet. So far, out of our 10,000, we have 200 with X. We have 9,800 without X. Out of these 200, we have 194 true positives. So we have correctly diagnosed 194 of them, but we have missed 6. We have 6 false negatives. The test is negative, but it's wrong. Out of the 9,800 people who do not have X, we correctly diagnose 9,506 of them. These are true negatives. But that means we miss some, or we incorrectly diagnose some. There are 294 false positives. These people do not have the condition, but the test indicates that they do. So, back to the original question. How many positive test results out of the 10,000? Well, it's going to be the 194 true positives and the 294 false positives. So 194 plus 294 equals what? 300, 488. I always check these things nowadays. Yep. Positive test results. So this is a mixture of positive test results that are accurate and positive test results that are not. So if you receive a positive test result, what are the odds you actually have X? Well, we have to look at the sample space. There are 488 positive test results, but only 194 of them are true. The other 294 are false. So this is true out of all the possible. So 194 divided by 488 times 100 gives me 39.7%. So not likely. We can also do the question, if you get a negative result, what are the odds? We'll do that quickly here since we're racking up the time. So negative test results, well, there are 6 false negative, plus 9,506 true negatives. So that's 9,512 negatives. So if your result is negative, what are the odds that you do not have X? Well, the total number of negative results is 9,512. The ones that correspond to not having X, the true ones, are these. Right? So that would be 9,506. So 9,506 divided by 9,512 is 99.9%. So if you get a negative result, you can be very confident that you don't have it. If it's negative, what are the odds you do? You do have X. Well, again, there are 9,512 negative results, and out of them is 6. Right? So this is just going to be the rest of the probability there. We could get this by dividing or by subtracting from 100%. So times 100 is 0.06%. So not likely. So it's quite interesting. If you get a positive result, the likelihood of having the disorder is not likely. If you get a negative result, you can be quite confident. Either way, it's very unlikely that you were missed. So going back over those results, it's tricky thinking about where these numbers go, because the odds, if you receive a positive test, the odds of you having the disorder is quite low. If you get a negative result, the odds of not having it are quite high. So these are tricky numbers to deal with. I'll stop there.